Hi, Libby, Luke, and Haley.
Hi, Libby. Hi, nerds.
There you go. Okay. This is section 3.5. It's symmetry. This is going to be a real fast, easy, nice section. All that good stuff. There's some weird things on the homework assignment, but I'm going to go through that and I'll show you kind of like, yeah. Anyway, symmetry. What? We're going to go fast. Yep. Symmetry. Symmetry. There are two types of symmetry. Put them at the top of your paper. Number one, number two. Number one is line symmetry. That's the first one that we are going to talk about. And the second one is point symmetry. They sometimes will call it rotational symmetry. Okay, so line symmetry and point symmetry or rotational symmetry. We've talked about each one of these before. They're just going to go through it again. Line symmetry is kind of like the art project that you used to do in like elementary school where you'd fold it in half and then you'd paint on one side and then you'd fold it in half and unfold it and it's the same on both sides. Your line or your crease in your paper is a line of symmetry. Point symmetry is rotating it around. So you find a point in the center of something and then you spin it around and they're talking about point symmetry. Okay, so we'll talk about those things. Line symmetry is the first thing that they have going on here. And there's that. All right, so example 1, they say, does it appear to have a line of symmetry? If yes, right, yes or no. And if it's yes, draw all lines of symmetry and state how many there are. So this crab that we have going on here, does he have a line of symmetry? Yes. How many lines?
One. Down the middle.
Only one. Down the middle, there's where we draw it, and we're good to go. Okay, does he have a line of symmetry this way? No, because like the claws at the top are not the same as the claws at the bottom. So there's that. Okay, B, does he have a line of symmetry? Yes. Now we're assuming that he is symmetric. You know, sometimes they don't look quite symmetric, but anyway, there's that. How many lines of symmetry does he have?
3, 4, 5. 5.
He has 5 of them. You know why? Because he has 5 like fins or whatever on him. Okay. So any 5-sided figure, like a pentagon will have 5. A hexagon will have 6. Anything that has that many will have that many, right? Okay, so because he has 5 lines of symmetry, and they are all those.
I just wrote my exclamation point upside down. And I?
Okay, so yes, he has 5. C? No, he does not. Okay, all right. I know, no. And then we're done. We're done for that one. Okay, all right. So that is line symmetry. Not too bad. It's pretty darn easy. Okay, ready? The next one is rotational symmetry, or they'll call it point symmetry. I'm gonna talk about him over here. So point symmetry. We'll do 2 examples, and then I'll show you their examples. So first example, when it has point symmetry, let's talk about 2 things that they will have you label, and one of them is called the order. And one of them is called the magnitude. Okay, one of them is called the order and the other one's called the magnitude. So just example, in section 3.3, you guys just asked me this question about the ceiling fan or whatever it was with the 5 blades. You don't have to draw this thing whatever. Okay, he does have rotational symmetry. He rotates around and he maps on top of himself, right? Okay, so order means how many times does he map on top of himself? How many times? And then the magnitude is the number of degrees that he must rotate. D-E-G, I can't spell. D-E-G-R-E-E-S. So we'll go through those. R-E-E-S. There you go. So how many times does he map on top of himself and the number of degrees? So just looking at the ceiling fan, let's talk about this top blade. He can map, like spin from there to there, right? Okay, and that would be 1, right? He could spin from there to there, that would be 2. He could spin from there to there, that would be 3. He could spin from there to there, that would be 4. And spinning there to there, that would be 5 total, right? We can map him on top of himself. That is 5 times. Thank you, sir. Just set it there. Okay, that is 5 times, so his order is 5. That's what the order means, right? Okay, and then the magnitude is the number of degrees that he has to rotate in order to map on top of himself. You all right? Woo! Okay, so magnitude, number of degrees that he must rotate before he maps on top of himself. So, like how many degrees is it from here to here? How would we find that?
What?
How we did the total divided by the...
What's the total? What's all the way around?
360.
360. We would take 360 and we would divide by 5. And that is 72 degrees. So it's going to rotate 72 degrees before he maps on top of himself. So a little equation for magnitude. Woo, I'm all over the place. A little equation for magnitude is magnitude is equal to 360 divided by the order. Okay? And that's how you find the number of degrees. Okay? Good? So let's do one more example. Let's do like a rectangle or like a sheet of paper. Okay? So I have a rectangle.
I just spelled order wrong.
And we have order and we have magnitude. Whatever. Okay, rectangle, we have order, and we have magnitude. Okay, so if I rotate that rectangle, does he have rotational symmetry? Will he map on top of himself?
Yeah.
Let's say I rotate it like 90 degrees. If I rotate him 90 degrees, will he map on top of himself? No, because he'll be up and down like this, right? Okay, but if I rotate him 180 degrees, like half of a turn, yes, he will. What's his order going to be?
1, 2.
2, including the full circle, right? So he would have an order of 2. If I rotate him 180 degrees, he'll be like this. And then if I rotate him again, he'll be on top of himself again. So he has an order of 2. So magnitude would be 360 divided by 2, which is 180 degrees. You can rotate that sheet of paper a half of a turn, which is 180 degrees, and that will map on top of himself. Make sense? Okay, so that's a rectangle. Good? All right, example 2. Let's go through. State whether the figure has rotational symmetry, yes or no. If yes, find the center of rotation. We didn't do that before, but center of rotation, then state the order and the magnitude. So those 3 things we have to answer. So A, does he have rotational symmetry, yes or no?
Yeah.
Yes. So he is a yes. We have to state the order. We have to state the magnitude. And we have to label his center of rotation. Where's the center of rotation going to be?
Right in the middle.
Like right in the center. I know that seems kind of silly that we would have to do that, but whatever. Yes, order. Okay, so he is a hexagon. 6 sides.
Mm-hmm.
Yeah. What's the order going to be? 6, right? Like this guy could map to here or to here. That's 2, 3, 4, 5, and back to the beginning would be 6. So he has an order of 6. The magnitude? 360 divided by 6, which is 60 degrees. That's his magnitude. Okay, makes sense? Good? Okay, what about B? Can you rotate that thing on top of itself? No. No, he doesn't have rotational symmetry. He's a no. Just because he is a scalene triangle, because all 3 sides are not the same, or none of the sides are the same, I guess. Scalene triangle is not going to work for part B. Good? C. Will he map on top of himself?
Yes.
Yeah. You think so? Yes.
Yeah.
Yes. If you like flip your paper like around, like do a 180 degree turn, does he curve the same way?
Yep.
Yes. Okay. So yes. And then we'd have to do order, and we have to do magnitude. And where's the center?
In the middle.
In the center, right? In the center. Okay. So order, magnitude. What's the order? 2, right? You could do a 180 degree turn or a 360, and that's 2. So magnitude is 180. The first time he maps on top of himself is 180 degrees. Now, before you flip, Kyle and I had a discussion beforehand, before we even started the notes, and he was like, okay, if it has line symmetry, does that mean it has point symmetry? Or if it has point symmetry, does that mean it has line symmetry? Like, if it has one, does it have to have the other? Right?
It depends.
Then it
Okay.
has,
So this one has point.
yeah.
Yes. But doesn't have.
Does it have line?
No.
Okay, right? You can't draw a line straight through here and flip him on top of himself because he's like waving the wrong direction. So he has point, but he doesn't have line symmetry, right? Okay. Let's talk about this little crab up here. He has line,
But no.
but can you rotate him?
No.
No point symmetry, right? Okay. Now there's some that have both, right? B has lines of symmetry and rotational symmetry, right? That's so some of them do have both point and line symmetry, but just because he has one doesn't necessarily mean he has the other one. Make sense? Good? Okay. Let's go to the back side. This has coordinate planes and stuff here. So it says, does he have line symmetry and or rotational symmetry? So we're just going to answer these questions. Does he have line symmetry? Does he have point symmetry? Okay, and then we're going to label where the lines are located, where the points are located, etc. Right? Okay. We'll tackle those for each one of these. So line, point, line, point. We're going to say yes or no, and then identify the lines and points that he's rotated around. Okay? Okay, so line. Part A is a rectangle. Does he have a line of symmetry?
Yes.
Yes. How many? 2. Okay, so let's identify the 2. Number 1, number 2. He has a line of symmetry going up and down. Where?
To the
Half.
It's at the half mark right here, right? Okay, so since we're dealing with coordinates, right? What's the equation of that up and down line? It's yes, it's at half, but is it x equals half, y equals half? What is it?
It's y equals half, isn't it?
no, it's X.
It's cutting through the
The
x,
X.
so it is at x equals half. Like you go over to half on the x-axis right here. Half on the x-axis would be on the x. And then he has another line of symmetry that's going horizontally. I think it's at the 1 mark, but that's going to be at y equals 1, right? Happy with that? Okay. So, yes, he has 2 lines of symmetry. Point symmetry? Does he have point symmetry?
Yeah.
Yes, he has point symmetry. Okay, now where's the point located? Where's that point located where he has point symmetry? Yeah, where those 2 lines meet each other, right there. Okay, so it's at 1/2, comma 1. That's where, scroll out. 1/2, comma 1. Okay, and then let's do the order and let's do the magnitude. So what's his order? How many times is he going to flip on top of himself? 2, the magnitude has to be 180 before he flips on top of himself. So that one has both of them, right? B, we're going to see if he has both. So I'm going to scroll over. B, does he have a line of symmetry? Yes, how many?
1.
He only has 1, and it's going straight up and down, right? At what? X equals -1. Okay. Now we talked about this first period, and I said, okay, what this is not a line of symmetry going diagonally. That's not going to work. He's not going to be the same on both sides. What would have to happen to that triangle in order for that to be a line of symmetry? Going across it.
Rotate it.
No. If that one would work and this one would work, what type of triangle would it have to be? What would have to happen to that triangle in order for those lines of symmetry to actually be lines of symmetry? Because right now this triangle is short and fat, right? Short and wide, kind of. Right? What would have to happen to that triangle in order for him to be the same? Or to have 3 lines of symmetry?
I don't know.
I have no idea.
I'm trying to draw and I can't even draw it.
Be the same way you said.
Be the what?
Like the same length.
The same length. What's that called?
All 3 sides.
Equilateral, right? If it was equilateral, then I would have 3 lines of symmetry, right? But the fact that he's short and fat makes it only have 1 line of symmetry, right? Right? But if it was equilateral, then he would have 3 lines of symmetry. Make sense? Does he have a point or a rotation of symmetry?
No.
No, because even if I put one in the middle and I rotate him around, he'll be upside down, right? Okay, so this one's a no. Good? Happy with that? That's it? All right. Oh, let me go to your homework assignment. So you guys don't have this yet, but let me show you some things. So on here, this is really speedy quick. On practice side, you have number 6 that looks like this, okay? And they're asking you for rotational symmetry, whatever. And they say, does he have a rotational symmetry? Okay. I've had people come through and nitpick this. They're like, I think this distance right here is a little bit smaller than this distance right here. They're just going ahead and saying that they're the same. Right? I looked up the answer and I'm like, okay, are they meaning to put them different? I think they just screwed up and they couldn't, whatever. Or maybe it's the way that it was photocopied. I think maybe the way that I photocopied it made it had a ripple in it or something. Okay, so pretend that those are equal distances apart, even though they kind of don't look like it. Okay, now number 8 also,
What?
you see number 8? Okay, is this the same as this? Well, it doesn't look like it, but I think the way that I photocopied, they want it to be the same, right? So pretend that they are, for this problem, pretend that they are both the same, because I think when I photocopied it, it got a ripple in it or something to make that smaller on one side. So pretend that those are the same. Anything that's supposed to be the same is, I think those are the only 2 that were questionable. I think everything else kind of looks ish the same, whatever. Okay. Yeah. So there you go. All right, those are the 2 weird things. Otherwise, everything else pretty easy. Okay, bye, 1 act people.